Welcome to this introductory tutorial about shell scripting, where together you will slowly learn about the syntax of shell scripting and more particularly the Bourne Again Shell, also known as Bash. Bash definitely comes on top of the list when doing research about shell scripting, but there are a lot of many other shells, C shell, corn shell, C shell, and what else? There are plenty of shells out there, but Bash is definitely the most popular and it's definitely practical also for a lot of use cases. Yeah, I guess you already have your own motivation for learning Bash, but if you need some automation, it's definitely very good motivation. Yeah, you can automate a lot of the tasks that you do manually, especially when it comes to CI/CD, system administration task, or even personally, if you want to back up all your data from your phone also, then you can write a little script to automate all those tasks and not do them manually anymore. So there is definitely, yeah, a lot of potential for what you can do with shell scripting. So yeah, happy learning. We'll try to discover them together, yeah, slowly. To follow along, you will need a Linux distribution with Bash installed. But if you do not have a Linux distribution available and you are on Windows, you can use Git Bash. Will also be possible. You can just install Git Bash and then use the Git Bash terminal to try out the different commands that we'll cover in the tutorial. But if you also do not want to install Git Bash, it's possible to use the website makecompiler.io. It's provide an online instance of Bash. So on the main website, we can just type in Bash and just open a Bash instance. So basically in the IDE in the editor on the left, you can type in some Bash commands. To have them execute, you just press the run button and the command could get executed. So basically you can also use this online editor to follow along and try out the different syntax of the Bash that we will learn throughout the tutorial. So yeah, enjoy and have fun. And keep in mind that the best way to keep the syntax is to try out by yourself. Yeah, that's the best way to get to pick up the syntax of Bash. So don't hesitate. Open up the browser. In the case where you do not already have a Bash available, and then open my compiler and yeah, just give it a go and have fun. One important and interesting thing to know about shell scripting in general, not Bash specifically, is that there are two types of commands, in Linux in general or in shells. Yeah, there are external commands, and external commands are commands that comes with the system already pre-installed or additional tools that you have installed in the system. Yeah, and as long as those tools are accessible in the system path, you can directly call or execute those tools from the terminal or from your shell. So what is important to know is that when you run an external command in the shell creates a subprocess to run that command and then return the results in the console. So, and in the case of a chain or a pipe of commands, like where you pipe multiple commands together, then multiple sub-processes are created and the output of one is passed as the input or the other and so forth. And those the result is also returned. So basically every command that is executed in a shell is a sub-process, and that's definitely good to keep in mind. And on the other hand, there are built-in commands, and built-in commands are, as the name implied, pre-built already in the shell itself, so that when you call those commands, it does not create a sub-process. Yeah, it gets executed directly in the context of the shell itself. So those are more efficient, yeah, because it's not very much needed to create a sub-process all the time. So the recommendation here is that while writing a shell script, So whenever possible, use built-in commands. Yeah, only refer or to external commands when there is no alternative or no equivalent built-in command, then you can go for a external one. But if there is a built-in command that also provide an equivalent feature, then use it. Will definitely make your script more effective. And now let's jump right in and get started with the basic concepts of Bash. And as with all programming languages, the first program, the famous Hello World, is written. We'll just do the same with Bash as well. And Bash provides the echo built-in commands that allows to print some messages. And maybe one hint from the getting start, even before the Hello World, there is a built-in command named type. And when you use type followed by the name of the command, it tells you if the command is a shell built-in or not. And that with that you can identify any commands if it's a built-in. If it's not a built-in, like for instance the ls command, here it says ls is alias to ls/color, and I can actually give also the path, and then it will tell me hello, bin ls is bin ls, so it's not a built-in, but type. Printf, for instance, is also a shell built-in. So as a head start, that way you can easily identify which commands are built in or not. Yeah, but now let's get properly started. So the echo command is a built-in command that allows you to print a message. So you can just use echo hello world, and then we get the echo hello world printed. Notice that here a new line is automatically added with the echo command, right? And if you want to print without a new line, there is a -n option, and then echo will not add a new line. And then you will notice that we have the hello world printed, followed directly by the shell prompt. Yeah, but by default, there is always a new line added with echo. And the double quotes are also not required. Echo just prints all its arguments, no matter hello world here and there, and it will just print every of its arguments. So the double quotes are not like strictly required with echo. But the single quote can also be used and to print messages. There is a difference, although single quote is literal string, but double quotes allows the shell to do some shell expansion, which is also an interesting topic that we'll try not to cover here right at the beginning, right? So for now, just keep in mind the echo command helps you to print some messages from the shell, and using it in the script is exactly the same. So I'll just add hello world to the script here. And to execute the scripts, we'll just run bash. The name of the script is 01hello.sh, and then the script will just get executed. There are slightly different ways to make this string, the script executable, but we will not go into that much of a detail, right? We will start slowly, so that you pick up like the foundational syntax of the language. So that is for the echo commands. And one interesting thing also is that echo allows to print special characters. And to print special characters, there is the -e option. So let's say that we want to print hello world in color. So there are color strings. I have prepared 2 of them here in the color.sh script. So I'll just copy the color string here. Oh, that's the reset color string, but I want the reset color string disable any color that is added. So I want to add the color yellow first, for instance, and then print hello world, and then disable the color at the end. And see, here I just forgotten to add the -e option, and the string is printed like literally. Yeah, so if we want echo to interpret those special characters, we just need to add the -e option, and then we have the string printed in color. And to refresh about the different options available with echo, also in bash in general, there is the help command, and you just type help followed by the name of the command, and then you will receive the help of the available options, right? We just covered the -n option, which make echo not to add a new line automatically at the end of the string, and also the -e option that allows to print special characters in the string. So whenever you forget, then you can just use the help, and then you get a quick reminder. And about the color string as well, do not bother much about them. If you need them, just Google them, and then you'll have a whole list of them on the internet for sure. So that's it for echo. So echo test to print default way if we do not want a new line to be added, -n, yeah, and the string is printed without a new line, and -e if we want to print special characters. So that is for the echo. We also have a second option to print strings with bash, and it's the printf built-in command. So type printf, it's also a shell built-in, right? So with printf, it's possible to use printf followed by the message to print, but by default, the printf add no new line. Yeah, so it gives complete flexibility. If you want a new line, you should explicitly add it. Yeah, so if we want a new line, I'll just add \n, which is the new line character, and then we'll have a new line. But printf also supports like format specifiers. So it's possible to give as the first argument a format string. And after this format string, the arguments that we wanted printf to use for the format string. So the format specifiers are similar to the one available on C. So if you're familiar with C, you probably know all the format specifiers already. I just add a couple of them here. So %s is a format specifier for strings, %d for integers, %f, %e, and %g for floats. Yeah, so the way the format specifiers work is that when you type, we have printf, and we want to print, let's say name is something, we want to add the name here, and that is the format string. So s is a placeholder, and after the format string, then the first argument that comes will be replaced with the first placeholder encountered. So if I say here Bob, then it will print name Bob. Of course, I will just add a new line so to make this easier to read. And if there are many format specifiers, they will just replace one by one in the order in which they are encountered. Yeah, one after the other. So it's in exactly in the order in which they are listed. The argument should be listed in the exactly following the order you have in the format string, yeah, so that they get replaced. So for the example here, we can just use the printf to build up to print some strings. So let's say we have printf, and to demonstrate the flexibility that printf gives, we will have here, let's say we have a format string, and we want another format string here. So the first would be name. We want name, semicolon, and followed by the name, which is Bob, let's see. for now, and I will add a new line, or I'm adding this to the run script. I want this to stay in the hello world script. And then I'll just call my script, and then I get name Bob. But let's say that we have many different attributes about a specific user to print. Let's say age and town. Asheville, and age, let's say 30 for the age. So if I run this, yeah, although it works as expected. Yeah, but it's not aligned. So let's say I want them to be all aligned. And this is one of the cases where the printf command is pretty handy. So I can make them all aligned with a simple trick. Let's say that I want this format string to always occupy 10 characters. So I can do it like this. And by default, if I specify a number of character and that is bigger than the string that is should be printed at that place, then it is right aligned by default. So if I run my script, you see they are all right aligned. But if I want them left aligned, I just need to put a minus sign. It's clean to make a little bit easier, and then it's now left aligned and the columns are all aligned, and that's pretty nice. So that's one example of how printf could be used, but it gives you complete flexibility on how you want the string to be printed. Yeah, it's very handy for such use cases. And to demonstrate the difference between the floats %e and %g, for instance, let's say that I have printf and let's say a given value that I want to be a given value that is a float, and let's say it's this value right here, and I add here a new line. So with the %e, it uses scientific notation, also with the exponential notation to represent the value. But if I used %g, it will let the printf command to guess and use the most suitable simplification format to print it. Yeah, so sometimes it's pretty handy. So the format specifiers are definitely pretty practical and gives you the flexibility to lay out the message or what you want to print the way you see fit. So now the next interesting thing that we will cover now about commenting, because commenting is very important, especially with bash scripts that could sometimes get very complicated to read. So it's nice to add some comments, and the pound character is used to add comments in bash in general. So I can use pound and example of hello world script. So everything after the pounds will not be interpreted by the shell already. Yeah, and it also in interactive shell is the same. Yeah, so pounds is the comment character in bash. There is also column. Column is not a comment character, but it's a command. Actually, we can also check it. It's a built-in command, which is a no operation command. So it's a command that does nothing, and it can be practical to use it for comments sometimes. So if I do column hello world, it will simply be ignored because column is a command, it's a do nothing command, so you will do nothing at all. So this is also equivalent. This is can also be considered a comment. Yeah. And if we run, we will just have the hello world and our Bob printed out. And with the colon command, it has the nice trick that you can use it to have multi-line comments, because with the pound character, if you want multiple line, you need to add a new pound to every new line to make the line a comment line, right? But with the colon command, you can use double quotes or single quotes to make a command multi-line. So this is an example of a multi-line comment. Yeah, so it's a do nothing but take this whole string as an input parameter, and then this way you can have comments covering multiple lines without the need to add every time the pound character. Make the comments, make good use of comments, because in bash scripts they are definitely valuable. The next thing to cover are variables, and for variables I'll just add a new script file to variable.sh. To declare variables in bash, the syntax is very straightforward. You just use the name of the variable, equal, which is the assignment symbol, followed by the value that you want to assign to the variable. So here I can have a variable name, for instance, equal, and I want it to be Bob. And that I have created a variable that contains Bob. And if you wonder what variables are, in general, variables are placeholder in memory where you want to put some value and reuse it afterwards in your script, right? Or a more general concept of variable, that's what it represents, like a placeholder, a place that you reserve in memory where you want to put some value and then you want to reuse afterwards. Yeah, that's what a variable is. So yeah, this is how to declare a variable in bash. Yeah, the name and the variable, it does not have to be in all cap. It can be lowercase, also fine. Bob is also fine. You can start with underscore, is also okay. Name, not none. Bob. So yeah, so there is no it does not have to be in uppercase. I do not think that a variable could start with a number. Yeah, in general, it's not allowed. Let's see. Of course, yeah, because variable should not start with numbers. It can start with underscore or alphanumeric characters afterwards. Yeah, I can do name underscore 2 or name 2, and this is valid. Yeah, but the first character should not be a digit. Yeah, that's not correct. And before we cover declare, the $sign character is what is used to do a variable expansion. So basically, if we want to get the value that is stored in a variable, we precede the name of the variable with the $character, or it's also possible to use the $ and the braces here to wrap the name of the variable. So if I want to get the value to return to print out the value contained in the variable name, I can do $name and then I get Bob back. Or it can also be wrapped inside braces and then it prints Bob back. So why the braces could be handy? Let's say that I want to print, I want to generate automatically some username, and it should be based on the name with underscore user afterwards. Yeah, let's say I'll add some comment here. I want a username that will be based on the variable name with literally underscore user. Yeah. So if I create my user with name, let's say my user is Dole, and if I just do echo dollar name user, then let's run it. You see that nothing is printed. Yeah, because the whole string name underscore user is interpreted as the variable, which is not correct. The variable is just name. I just wanted to have in the end, if my value is name, for instance, you have an example. If name is Bob, I want my automatically generated username to be Bob underscore user. Yeah, that's what I want. But this does not work because Spark is interpreting the whole user underscore name as the variable name. And that's where the braces comes handy because it delimits clearly where the variable name starts and where it ends. So I want to wrap the name with the braces, and then it's explicit that the name of the variable is name because the braces define where it starts and the closing brace define where it ends. So if I run the script again, now I have my expected automatically generated username, Doe underscore user. Yeah, that's why the dollar with the braces syntax format is very handy. Now that's the variable is declared. So just to make it complete, it's also possible without the double quote to use Bob like this without quotes at all. Yeah, it will also automatically be a string. And I can also use single quotes. So to create a variable using this syntax, the variable in the end is always a string. So even if I do age 40 like this age variable is still a string at the end of the day, even if I do not explicitly add the single quotes for a literal string or double quotes to it. Yeah, that's good to keep in mind. So I'll just add age, variable age here, 40. And then the other way to create variables with bash is to use the built-in declare command. Yeah, the shell built-in. So it comes with bash already, and to declare a variable using the declare command, we just use declare the name of the variable and the value. So basically it's the same sentence as before, just that there is now declare before it. Yeah. And why declare is nice, we'll just see it in a moment. So this way we have also declare a variable, for instance here, name, which have the value Tom. And declare, with declare, we can actually print with -p, we can print the variable. Yeah, and declare print out, okay, we have declared a variable named with the value Tom. But where declare comes in handy is that it have the possibility, it gives the possibility to add some option or attributes to the variable. And so with declare, we can use the -i option to create an integer, and the -l option to make the value stored inside the variable lowercase, no matter what the input was. The -u to make the value always in uppercase, no matter what the input is. And the -r option to make the variable read-only, which would be the equivalent of creating a constant. Yeah. And -x to export the variable. So basically making the value, making the variable accessible to other scripts as well. So we can try this out. If I want to declare an integer, I say declare -I age 40. Yeah, and so if I use the print option on age, declare also keep the attribute for it. It says like you have the -I flag. It shows here the value with double quotes, but it starts as an integer. So that's how to declare an integer with bash. And let's try out the -L option. With the -L option would be lowercase. So if I declare Tom like this, and if I print the name, it would be lowercase anyway. So it does not matter if I said town bash fill, all messed up, and I print the town, it should always all be lowercase. So that's pretty handy if you want to convert a variable to a specific case, lowercase, for instance, then use the -L. If we want to make it all uppercase, we can use -U, and then it will automatically be uppercase. Yeah, that's very, very nice. And the -R option is to make the variable read only. So basically, if I do -R option or town equal bash field this way, by reading it, we will it's still all cap because I have enabled the uppercase previously. Town, we have the attribute read only and the -U. So far so good. But if I said, let's say I want to overwrite the value in of town with, I don't know, Pythonville, then it will complain Tom is read only. So it's the most straightforward way to declare a constant in bash. It's also possible to use the read only built-in command as well, but declare is also right. So that's how to declare variables in bash. And keep in mind the declare with these options is definitely very handy and better than using external tools like TR to do case conversion, for instance. Now that we have we know how to declare variables, it's also good to know how to delete or remove the variables. To delete, so far we have, for instance, the variable name. We can use declare with print. Then we have variable name, for instance, created. If we want to remove it, we can just set the value to an empty string. Then it's gone. Or equal with nothing at all is also possible, and then it will also get deleted. But the most explicit way to do it is to use the onset built-in command. So onset /v for variable, and then the name of the variable to onset, and then it will clean it up from memory. So that's pretty explicit, because with this option, for instance, variable equal, it could be a mistake. It's not sure, but onset and the intention is very explicit. That's the programmer of the script wanted to clear the content of the variable at that point of time. But what is not possible is to unset a read-only variable, because we said that read-only is the way to create constants, and you cannot remove or overwrite constants. So town was declared with read-only in uppercase, so we cannot do onset town. Bash will complain, cannot onset read-only variable. So it's not possible to unset read-only variables, but only any other. And it makes sense, of course, because if it's read-only, it's constant. We want it to be so. And it's definitely nice because if you're declaring global variables, it's better to have them read-only so that we're sure that it cannot be mistakenly overwritten somehow in between the scripts and changing the behavior of your scripts. So when you're declaring global variable, just consider enabling the read-only option on those just to guarantee the integrity of it throughout the entire script, and use like local variable for any other use cases. But we will also cover more about local variables when talking about our functions. Spatial variables. Yeah, spatial variables are variables that are provided by Bash itself, and we'll cover these now because they're quite handy for what we will see afterwards. Spatial variables. So the spatial variables, or the list is right here. Star is the spatial variables that expands to all the positional arguments of a script or a function, but that we'll see it later. The at is also a spatial variable that also expands to all the positional parameters of a script. But there is a slight difference between the two. Yeah, with at, the word splitting of Bash occurs, and with star, word splitting does not occur. And what this means, we will cover it when we see loops. But for now, just keep in mind that star expands to all the positional parameters of a script, and add also expands to all the positional parameters given to a script or given to a function. So we can just do some tests here. So add the variable can be this way, because we said that dollar is used for variable expansion, and the variable itself is star. So if we want to see all the values, we should precede it with star, of course, so that the expansion will happen. And it can also be done with the braces, yeah, dollar braces, and the name of the variable is star. So to run this script, it's if I let's say I give arguments 1, argument 2, argument 3 to the script, then you see it prints like all the argument that has been provided, and this is what it means expand to the positional parameters that are provided to the script. And the same for the add spatial variable. So add also expand with a slight difference that we'll cover later on, but these two notation are all valid. And if I run the script again, you see for the star it's expand, and for add it's expand, and from this perspective you will not make the difference, right? Because both expand to all the positional parameters that has been provided to this script here. The next spatial variable is the pound, and pounds expands to the number of arguments that has been provided to a script. So if I do let's say number of args will be $pounds would be the value of the variable, and can also wrap it with braces, also valid. And if I run the script like before with the 3 arguments, then it will print 3 because we have 3 arguments. If I added another argument, let's say 4, then it will say, okay, the script has 4 arguments. So this returns the number of positional arguments that have been provided to the script or to the function. There is then the question mark, which is a very nice one. The question mark special variable return the status of the last command that has been executed. So if I do this, it will print the status, the last command at this point of the script, the last command line to be executed is line 15. So this will return the status, the exit status of line 15. And if I add a second with the braces, these two does not show the same exit status. Of course, they will both show 0 because the commands, the echoes will run successfully. But this one shows the status of line 15, and this will show the status of line 16. So they are both showing exit status. And if I run the scripts, yeah, I will see 0, 0, but the value is the same, but they are not returning the same exit status. And to give a little bit more example of this, let's say that I use the ls command, or instead of the ls command, I just type a random command, random something, which is not a valid command at all. And of course, Bash will complain, command not found, which is normal. And then I could check the status with $question mark, and then the exit status of my like dummy command is 127, which is standard for Bash for command not found. It's 127. But if I re-execute again, then I get 0 because the last command that has been executed now is no more my invalid command that I've provided, but was the echo. So basically, if you wanted to check the exit status and do some other stuff in between, it's better to save it in a variable, and then you can check it later. As soon as you run another command in between, then the question mark special variable will refer to that new command executed. So it always refers to the most recent command executed. The next one is the dollar special variable. Dollar, we use it for variable expansion, but here it's also a special variable. And it returns the process ID of the process ID of the active commands, basically. Process ID. So if I do, this would be, so the first dollar is for the variable expansion, and the variable itself is the second dollar. So basically this is also valid. So I have my dollar braces for the variable expansion, and dollar is the name of the variable. And this will return the process ID of the command. And you'll notice that if I execute it again, it will be different, because every time I run bash followed by the name of the script, it's another process that gets executed. So the process ID will change. Yeah. So dollar always refers to the process ID. The question mark is the variable that refers to the most recent job. It refers to the job ID. And what a job is a topic that we'll cover later when covering coprocesses. Here I have started no job. So if I do echo dollar or echo this way is also valid, it will just return nothing because I have started no process. But this will definitely be covered again when talking about coprocesses and jobs. The zero is also a special variable. 0. Yeah, and it returned the name of the script, or the name of the file that is being, of the script file that is being executed. So the variable is then $0, because the name of the variable is 0 and we want to expand 0. And can also be done this way. It's also valid. And then this, the script is 03 special variables, and then that is what would be returned with this, yeah, 03 special variable. If I do it from the interactive shell, then it will just return bash, because yeah, here bash is what is being executed. But yeah, definitely practical when trying to print debug messages from multiple scripts. Then you can use the 0 special variable to refer to the name of the script, yeah, to help find out what is going wrong and where. But not only the 0 variable, you can maybe already cover a little bit about there are also variables that are dynamically created, that are 1, 2, 3, and so forth. And those are just, those refers to the positional arguments given to the shell scripts. So the first positional argument, we have just seen that 0 refers to the name of the script itself. But the first positional argument given to the script will be available in the variable 1. Yeah, that we can also refer to this way. So if I run my script this way without argument, basically only the 0 will exist, because this always refers to the name of the script that is being executed. But if I add no script, then arg1 will not exist. But if I add an argument, let's say name, to the script, then the variable 1 will refer to that positional argument. And if I add, as I could use, although the positional arguments are dynamically created. If I add 2 arguments, then 2 will be available. If I add 3 arguments, then 3 will also be available, and so on. So there is no limit. If I have 2 and 3, for instance, then I will have name, town, city, and those 3 would be available. So that's it about special variables. Just keep in mind, this is very important one. The question mark special variable that return the exit status of the most recent command executed. Very handy. The positional, the variable referring to the positional arguments, also practical. The 0 special variable that refers to the name of the script being executed, and the positional argument that expands to all the positional argument provided, star and that being said, now we can cover the standard inputs, outputs, and error. And what is most famously known is that on Linux everything is a file. Yeah, which is, yeah, correct. Everything is a file. Also good to keep in mind that to each open file in the system is associated a file descriptor. And the file descriptor is actually an integer that uniquely identified or uniquely reference the open file. And that file descriptor, which is that integer, can be used to interact with that file, meaning can be used to read the file, to write to the file. And we have 3 standard of such file. The standard outputs, which is the terminal. That's where we get some feedback from the program that are being executed. So for instance, when you do echo hello world, we get the message from the standard outputs, and that's what we see. To get information into processes is the std_in there for that, and the standard error is used by programs to print out error messages, which is also a separate file. So each of these standard out, standard in, and standard error are files and refers to file descriptor 0, 1, and 2 respectively. So standard in refers to the file descriptor 0, the standard output refers to a file descriptor 1, and the standard error refers to the file descriptor 2. So basically, if we want to print something, we just need to write to this file descriptor and the message will get printed, which is somehow what echo is doing, or printf that we've seen before. So why is this relevant now? Then comes the next slides, because we want to talk about redirections. Programs act in a specific way by default. So echo just writes to the standard output by default, but we could wish echo, for instance, to write into a file. And to write into a file, there is the redirection operator, which is the greater than symbol, as seen here. And then we give in the file name where the output, or where the standard output should be written, and then the standard output will get written into that file and will not be printed into the terminal anymore. So as an example, we can do hello world, and then use the redirection operator and say hello.txt. And then we do not see the message here anymore, but a file gets automatically created and contain the hello world message. So that is how the output of a command can get redirected, for instance, into a file to save it. And how this works when if the file does not exist, the file is created. If the file exists already, the file gets overwritten. So if I re-execute this, we will just get hello world. If I do hello YouTube, then it will overwrite it and we get hello YouTube automatically. But then comes the append command. So this also, the double greater down symbol is also a redirection. But if the file already exists, it appends to the end of the file and do not overwrite it. So if I turn this, let's say with the append, we now have hello YouTube. And if I append now the hello world to it, then in the file we'll have both lines. Yeah, and if I re-execute this many times, the file will get extended every time I execute it. So the double greater than symbol is used for redirection, but to extend the file if the file already exists. And the single one just overwrites if the file already exists. That's the main difference between the two. By default, the standard output gets written into the file, but it's also possible to put a file descriptor, and that's why we have covered the file descriptor on the previous slide. So if here, when we add 1, we precede the redirection operator with 1, it means that we want to redirect this file descriptor into the file name. So basically, we want to redirect the standard output into the file name. So this is explicit. Without specifying anything, it's already the standard output that is being redirected. But adding the 1 here, it's like we are being like explicit about it. So can use 1, and notice that there is no space between the 1 and the greater than symbol. They are written all together. Yeah. And then it's telling redirect the standard output into the test for me, please. And 1, that's it. That's standard output. And if we use, we refer to 2 is the standard error. Here, file descriptor 2 is the standard error. So basically, we can explicitly also redirect only the standard error into a file. So let's say I call the file errors.txt and I run it. Now we get the message printed in the terminal because we are not redirecting the standard output anymore, but the standard error is being redirected into a file. So the file has been created, but since no error has occurred, then we get nothing printed. But let's say I put a weird command that does not mean anything and I execute, we have nothing printed, but this time the error is written into the file because we are redirecting the standard error into this error.txt file. Or let's say I'm using the ls command, I'm redirecting the standard output to lx.txt and the standard error to the file. So I can also combine both. Here, I do not need to specify one because by default, it's already the standard output that is being redirected. And I want to redirect the standard error into this test file here. So it's possible to specify both at the same time. So now we have an lx.txt file that has been created that lists actually the content of the current directory. And the error.txt file is simply empty because no error has occurred. But if I add an option that does not exist, for instance, then an error will happen. And the error got written then into the error file, unrecognized option. So that's it. So it's could be preceded with a file descriptor. A file descriptor which is an integer, that uniquely identifies an open file on the system to redirect it into another file. And here we are redirecting the standard output and the standard error. There is the ampersand followed by the greater than symbol, which is the redirection for both standard output and standard error. So we do not want to redirect them separately. Let's say, for instance, we want both standard output and standard error to go into the same file. So if we consider the LX example, if I want to redirect both standard error and standard output into the lx.txt file, then I just use the ampersand followed by the greater than symbol, and then both will get written into the file here. As there is no error, we just have the normal output of the ls command. We can also list, for instance, let's say only shell scripts, and then only shell script will get written into the file. But if I add again my dummy option that should create an error, then the error also gets automatically written into the file. And the last that we'll cover would be the input redirection. So far we have seen redirecting the standard outputs, the standard output and the standard error, these two. And there is also the standard input. By default, standard input is related to the keyboard where we can give some input to processes. But it's also possible to make a command read some input from a file instead of from the terminal. By default, for instance, with the cat command, and for the notice, cat is not a built-in command. Cat is an external command from the core utils. And it's in general used to concatenate multiple files together, just to provide some context, because I'm trying to cover shell itself without bringing too much of external commands in the context. But for the example here, cat is quite suitable. When a cat is executed without giving any arguments, it expects some value from the standard inputs, right? So we can type in some text, and when we type enter, it will echo back whatever has been typed. So whatever is typed, another test, then cat print is back, and it can be we can quit it by pressing Ctrl+C. So cat definitely expects some input from the standard input, but with this input redirection, we can use the lexdan symbol here for input redirection to feed cat with some text from a file. So let's say cat, please, instead of waiting for the standard input, use the file lx.txt, for instance, as your input, and then cat will use it and just print its content, and then exit. So this is quite practical to provide some input to a program that expects some input. If the input is already prepared in a file, then the input redirection is just perfect for it. So that's it about the input output redirections with the greater than or less than symbol. It's also possible to combine with the concatenation format. So it's possible to do, for instance, ls ampersand greater than, yeah, and then the ls file. And every time it's executed, the file will get extended. So they can be combined, yeah, to have the append form of the redirection. And without it, then the file will just get overwritten again. Now we'll cover pipelines. The pipelines are a way to chain commands, to run multiple commands together. And here we'll cover the ampersand and the pipe. Ampersand, let's say that we have two commands like shown here, command 1 and command 2. With the ampersand, it's like an end condition. Yeah, command 2 is executed only and only if command 1 has completed with a 0 exit status. Yeah, 0 means successful. So if command 1 has executed with a 0 exit status, then command 2 will get executed. But if command 1 failed, then command 2 will not be executed. In the second case with the pipe, if command 1 executed with a 0 exit status, then command 2 will not be executed. But if command 1 failed or executed with a non-zero exit status, then command 2 will be executed. So this case could be like whatever happened in command 1, if it fails, then use command 2 to do like a failure recovery kind of thing. So to show an example, so if I say echo hello ampersand world, then both will get executed. I'll get hello world because echo executes with a 0 exit status, and then it run the second command. But if I run I type some non-valid command here just for the demonstration, or I can actually type ls with my dummy option, which does not exist, so will fail. Then we only get the failure, yeah, and the words never gets printed. And here, for instance, is a nice way where we can do again our input redirection and redirect this into, for instance, the error.txt file, and then nothing get printed when the error happened, but this command will not get executed. But if everything worked fine, so I will just get rid of my dummy option, then we get the tests printed. Maybe we can have it a little bit nicer with the -1 option. And then we have all the files listed, one on each line. This is what this option is for, -1. And then we have the hello printed at the end. So both command gets executed. Yeah. And maybe for the example, there is also a command which is a built-in command, true, that always run with a 0 exit status. And as we have seen already the special variable for it, we can check it with the question mark variable, and the exit status of true is 0. And there is also the false command, which have an exit status of 1 to mean failure. Basically, for the test, I can do true and echo it worked. And then we'll see it worked. But if I use false here, then it work will never get printed, because false is a command that executes that executes within non-zero asset status. So just to show the example. On the other hand, with the pipe, so if I use true pipe echo it failed will never get executed, because if the first command terminates with a zero asset status, then the second command does not get executed anymore already. But if this failed, which is false, then it will show it failed. So instead of using the built-in true and false commands, can you use actually real case? So if I use ls echo, we couldn't list the content of the directory. Let's see it this way. And then since ls will execute it with a successful exit status, which is 0, then we do not see the error message. But if this fails, then we see we couldn't list the content of the directory. So these commands are actually very practical to handle successful cases. Oh, command 1 has executed. Okay, then we do the next step. And in this case, the command has failed, then we do a failure recovery. Maybe a process or an SSH session is being started, or whatever, a transaction about a database command or something is being started, and in the second stage, if a failure happened, then you execute the second command to undo something that had been started, or to do some cleanup. And the second part is the pipes. So with the pipes, the main goal here is to use the output, the standard output of one process as the standard input of the second one. So here the output of command 1 would be used as the inputs of command 2. And to demonstrate this, we can use echo with the cat command that we've seen earlier. Echo write to the standard output, and cat expects something from the standard on the standard input. And what the kernel does, or what Linux does here with the pipe commands, it creates a pipe which is a special type of file, and it writes the output of the first command into that file and provide that file as input to the next command. And then it's possible to chain more than multiple commands altogether, and the output of one will be provided as the input of the following one, and so on in the chain. So for a simple example, if I have echo iBob here, pipe, and then cut, so echo would be written into a pipe, and that pipe, echo Bob will be written into a pipe, and that pipe will be used as the input for cat, and then we'll just get the message printed. And to show that cat is doing something, we'll just add the option number, and then cat will number the line, which is 1, because there is only one line from echo. So if I combine it with ls in with this way, cat space number the outputs, and then the output of the ls command gets provided as input to cat, and cat will number each of the line. And we can even add, for instance, grep regex, and yes, .sh, and then it filter out only the .sh files, for instance 1, 2, 3 and color, and our shell scripts. So the output of ls is provided to cat numbered that output, and that output is provided to grep, and grep just got out only the shell script and get rid of the test files in this particular example. So it's possible to actually chain multiple. It's only 3 in this case, but it's definitely possible to chain much more. I can even do another grep regesp. I'm using the long options on purpose so that it's meaningful. Yeah. And let's say I'm only interested in the variables, and I can do variables. And then we only get these two at the end. ls got piped into cat into the first grep to sort out only the shell script, and then again into grep to only consider the file containing variables, for instance. Yeah, so with pipe, it's possible to build up a long chain, and the output of one command is provided as the inputs of the following one, and so forth in the chain. But let's say that I have the ls command with an invalid option, as I like it. I like the dummy option. And then I'll pop it to cat and number. And you see that here I just get ls unrecognized option, and that's it. But it has not been numbered by cat. And this is because the pipe only forwards the output of the first command to the next one. So the standard error is not forwarded. So if I want both standard output and standard error to be forwarded, then I use the pipe ampersand format. Yeah, and this is what this is there for. And if I run it again, there is still the failure, but the failure is forwarded to cat, and cat numbers it as well. So that's the difference between the two. The pipe with ampersand also forward the standard error. So both the standard output and the standard error to the following command, and so on in the chain. And you can somehow combine them. If I take the longer option here, it's possible to do this with ampersand and the other one with not. So you can use any combination that works for your use case. And then comes the topic of subshells. And subshells to create or run commands in subshells, you just need to wrap the commands with parentheses. Yeah, parentheses make bash to run the commands defined in the between the parentheses in a subshell. And when a command runs in the sharp subshell, basically it's run in an isolated scope. And when the command terminates, everything that is created in memory also dies with the subshell. So only persistent information that has been, for instance, saved onto the file or written into a database or something that modify the file system will be kept. Everything that is in memory will just die. It's just like creating a small scope where you can perform any change you like, and when you go out of it, then the changes are not valid anymore. So let's consider the small example here. Can declare the name Bob or Beep. No, Beep Bob, and I'll use echo to make it a little faster to type here. Name. So I just wanted to print name. Then I'll create a subshell name. I'll use all cap, so that it's like I'm trying to overwrite the name that has been declared before. and provide it with the value flean and echo name, still the variable name. Notice that while writing multiple commands on the same line, the command needs to be separated with semicolon. And then we just copy this to the end, and then this will be after. In subshell. Yeah, and this is after. So we can run this with, I think it's the 4th, yeah. So before the subshell, the name is Bob. In the subshell, it's clean, but after the subshell, it's still back to Bob because, yeah, the name has been changed in the subshell, and just, yeah, at the end, when we exit the subshell, then this change just vanish with it. And it's also possible to define subshell on a new line, not necessarily on a single line. So I can do this Thomas, for instance, and echo in another subshell name. Yeah, and then execute it. And then clean here in this subshell is Thomas, but in the end, it does not affect the global scope. Yeah, so those are what subshell are practical for. You want to execute a set of commands and want to keep them isolated from the global scope where you want to do some changes, and then afterward, as long as it's in memory, then the change will not be persistent out of the subshell. But let's say that I write here the name into a file, let's say name.txt. I use here the output redirection to write. So if I run it, I'll have the name Thomas in the file. So if I use that file outside the scope, then of course it will be persistent because, yeah, writing to the file system itself. Yeah, but every change that it's performed in memory, like in variables also, then gets automatically cleaned up when going out of the scope of the subshell. Grouped commands are also grouped commands.sh. Group commands are created with braces, and it's a little bit like with subshells, but there is a little hack. Notice that here I did not added, for instance, a white space around the parentheses. I could add, yeah, but without it's no problem. But with the braces, you have to add the white space around, because braces without the white space has another meaning. Yeah, it's for expansions, which will be covered later. So with braces, it's needed to add like white space, and the command should be in the middle and should be terminated with a semicolon. Yeah, so if I want to do grouped commands, I need a semicolon. Yeah, notice that my editor is even complaining already, yeah, if I do not add the semicolon. So the semicolon is needed when writing this in the form of a single line. So this is, for instance, a grouped command. And what's make it a group command is that I can write multiple commands inside the group. So I can also use this format like shown on the slide here. So I can you just put the printf hello, printf world, printf new line. And this will print hello world. And it printed hello world without space, of course. Then I add a white space here to have group commands from the first group and hello world with as expected. What is this useful for? Let's say I wanted to run a bunch of commands and redirect their output all together and not individually, then a group command is practical. So if I wanted to redirect each of these line into a file, I could do something like, let's say, I want to redirect this into the hello.txt file. And since I want all of them in, I will do append hello.txt and append hello.txt, right? So the first one will create if a file does not exist, or if it exists, it will overwrite it. But this one will append, will extend the existing file, yeah, with this two line. This will be a way to do it. And if I have this that contain already hello world, if I delete it and run my command again, I'll get hello world in it, yeah, because instead of world, I'll add here YouTube, and then if I run it, not only here, I want it to go into the file as well. Then hello YouTube, perfect. So it can be done on each line individually, but a more nicer way is to use a group. So I just need to redirect the group once, hello.txt, and everything that is being printed here will directly go into the file. And that's what a group command is helpful for or useful for. Yeah, to send the output or the error. Although it will also be possible to use to redirect the standard error or any combination of redirection that we have covered. Yeah, can be used on the group in whatever command. I can also define, let's say, an ls before it, and then all this will get written into hello when the script will get executed. So now we have the output of the ls command followed by what has been printed, and that's why the use case for which you want to use a group command for instance. But what group command do not do is to provide an isolated instance where you can do things, and outside I mean something like the subshells, it's not possible. It does not work that way. So if I have a name Tom here and I use before name, and let's say inside my group I change the name to Amy, in group command, and I check it afterwards. So here it's Tom, here it has been changed to Remy, will be printed, but here will stay Remy because a group command does not provide an isolated environment where you can just change whatever without affecting the global scope. So a group command also shares the same scope of the script where it's being used. Yeah, the scope is exactly the same. So if we run this, of course, the output does not get printed because I'm redirecting it to a file. There is a way to do both redirection and writing to a file, but would distract us from the main topic for now. So in grouped command, I'll just comment this to make the whole thing less noisy so that we just see exactly what we want. So before it's done, in the group it's Remy, and after it's also Remy because, yeah, as mentioned, the group does share the same scope as the script where it's being executed. Arithmetic expressions. Arithmetic expressions just for doing basic computations. And if you end up with the need to do complex computation with Bash, I think it's the right time to think about another scripting language like Python, for instance, would be way more efficient to do a lot of computation. But if you need basic utilities for simple computation in your script, then yeah, Bash also offer a mechanism for that. Arithmetic, .sh. And how to do arithmetic computation if with the double parenthesis syntax, and in between the double parentheses then you can perform any arithmetic operation that you need, and the arithmetic operation are pretty similar to the one available on most programming languages. The post incrementation, plus decrementation, the unary minus plus, the pre-increment, pre-decrement, the logical negation, and logical negation and bitwise negation, exponentiation, and so on and so forth. Order of precedence is from top to bottom and from left to right, basically. And this is just got it from the Bash reference guide. So it's definitely a nice read if you want to get like the exact explanation and the exact details, yeah, of how things are structured. It's definitely nice to give it a read. Yeah. But for the demonstration here for this, let's declare an integer, and I miswritten declare already. An integer that we'll call index and set it to the value, let's say 10. And then let's say we want to increment it. Yeah, so we use the double parenthesis index, and then I use the post increment. And then I just print in this. And here I can print before and after the increment, and then we could see, let's see, okay, it was 10, had been incremented. Now it's 11. We can use the assignment operators, yeah, like index plus equal 20, and then it'd be 31 afterwards. Yeah, and we can do the exponentiation index squared, and I'm not assigning the value, so I need to do index equal index squared, and then it's 961. All the typical arithmetic operations can be performed, and also logical operations. So let's say that I have a variable with an integer, and I name it words, and I want it to be 0f, for instance. echo word, print word. If a revert word, so let's say I want a bitwise negation of words. Can do words equal a bitwise negation of words and then echo word. And 0f is 15 for sure, and bitwise negation is 16, and it's 16 simply because it reverted the integer is a signed integer. Yeah, it does not, it hasn't treated, it's not treated as an unsigned. And we can do the shift operation if we have let's say, I will declare word 2, the other one was not 1, but let's say 0, 4, for instance, and I want word 2 to be shifted, so I use the shift left by 1 bit, and echo word 2, print it, should be 8. Yeah, if the shift word, if correct, here 4 shifted by 1 bit, yeah, should be 8. Yeah, exactly. So that's it. So for the arithmetic operations, although the list is here, I'll play around with it and yeah, try to discover them and get comfortable with them. All of these operations work, and it's quite practical if you want to for instance, directly, if you have some embedded device like a Raspberry Pi and wanted to play around with shell scripts and try to write directly in the proc file systems for the standard input outputs or so, then you can definitely use these bitwise operations to switch pins on and off and this kind of thing using Bash. Yeah, it's would definitely be interesting. Yeah, so that's it more or less about arithmetic expressions. But if I said you ended up being, if you feel the need of complex arithmetic operations, then it's probably the right time to think about using another scripting language like Python, or maybe Ruby could also be an interesting one. Yeah, just consider this.